So hi, everybody. My name is Josh Follett. I'm the co-founder and CEO of Robotics. And what an exciting time for Robotics Showcase, right? Like this is great. Like we're here, we're talking about, we're talking about drones that can follow you through a forest, right? That's crazy. We're talking about cars that can drive themselves, delivery robots that can go out into the city and bring you things, right? Arms that can pick up arbitrary objects. Like all of that's totally new. And if we had done this showcase just a couple years ago, none of that would be here. Right? So what changed? And the answer is robots became perceptive. We're now at the point where this machine can go out and see the world and interact with it and understand it. Right? Really remarkable. But with every solution comes a new problem. Right? And the problem this created is that perception data. The perception data coming off these robots is massive. It's hard to work with. The internet wasn't even really built for it. And to put it in perspective, a self-driving car, it's about 4 terabytes of data per hour. Right? Which means it's going to eat through your Comcast monthly data cap in about 15 minutes. Right? And it's unstructured, it's big, and it's messy. And that ends up slowing down development teams who are trying to build these systems. Right? And it gets you in a couple of places. And the first one is what I call the triage problem, which is there's all of this data out on the edge, out on this robot, and I need to bring it back to my engineering team so that I can start, actually addressing the issues that it's encountering in the real world. Right? It's a big challenge. And then the other we'll call the data warehouse problem, which is once I have all of this data, how do I make sense of it? Right? And those are the problems that Robotics exists to solve. And we address that first one in a couple ways. What we do is we go out to the edge, we do a clever combination of event detection, rendering of kind of video out on the edge, and some kind of clever compression, and that lets us take kind of gigabytes of data out of the edge and turn it into megabyte-sized previews. And once you kind of get down to that preview size, all of a sudden, now you have something that you can actually move up to the web, give to your engineers, have them take a look at. This is the inbox for our web UI, and then you can dig into an event, see what happened, decide which engineering team needs to get a hold of it, and then if you need to pull up that heavyweight data, you can at least make an informed decision that it's worth reaching out and uploading a couple gigs of data. In a lot of cases, you don't even really need to. And that's how we kind of address this triage problem. But then the second problem is, okay, so I've been doing this for a few months, and now I've actually pulled back petabytes of data from all of my robots, and I have it all sitting on my back end. Right? In order for that to be useful, it needs to be two things. It needs to be searchable, and it needs to be accessible. Otherwise, it's just a mountain of data. So we address that. We help with the annotation process. How do you pick what needs to get labeled? For your machine learning, we'll help you put that into data sets, and then making that all search and discovery. Which brings us to kind of the technical problem that's kind of interesting that we're working on, and if anybody here wants to contribute to, and that's search. What does it mean to search this really unstructured data? And the first pass of that is really easy. If you want to, or not really easy, but pretty easy. If you want to search for properties about an image, like let's say this is from our sidewalk delivery robot rolling through Palo Alto, I want pictures from a robot in these locations at this time. That's metadata search. That's pretty straightforward. Then there's another layer to that, which is I want to search based on things inside the image itself, right? That's a relatively straightforward problem if you know in advance what you're going to be looking for. During that ingest layer, during that triage step, you run an image classifier, you store the output, you use that as an index, you search on it later. Where things get more interesting is how do you search when you didn't know what you were going to be looking for when you did that indexing process? And that starts getting really complicated. Super valuable if you can do it, because now, our customer, the robotics company, can go back and look for things that they didn't know in advance they were going to need to look for. And then the fourth layer to search, and kind of the really exciting part to crack, is how do you search based on the event, right? So now I'm not just searching for a thing in a picture. I'm going, this is an example of my robot being stuck at an intersection because the LiDAR is occluded, right? Find me more things like that. Well, that spans data streams. You may or may not have even had an idea what those things you were going to be looking for were in advance, and that starts turning into a really, really complicated search problem. But the good thing is, for as hard as that is, there's value at each incremental step, right? It's just continuously getting better at searching, lets our customers pull out that data, makes better use, gets their robots to kind of address these real-world issues, and get to market faster. So if you have kind of this interest in doing this real multimodal search across these really complex data streams, please come find me afterwards. Thanks.